All right. Well, thank you very much for everyone joining us today. My name is Richard Simpson. I'm the VP of Business Development here at ZeroKey. And welcome to our webinar, Enabling Digital Transformation with Hyper-Accurate Location Services. We're going to have a little bit of an introduction into our technology, what it does, and how it applies to industry. At the end of the webinar, we'll have ample time for Q&A. So if you have any questions that haven't been answered throughout the webinar itself, then please shoot them into the chat, and Matt will be aggregating those for the end of the conversation. So who is ZeroKey and what is smart space? So essentially, we are a sensor technology company, and we make IoT sensors that are hyper accurate for tracking people, processes, whatever you want to track. The core technology is based on ultrasonics or sound. Our focus is essentially in the industrial environment, and we have a number of different applications there. And we view ourselves as being that transformative new technology that's really going to be able to drive the digital transformation in the industrial world today. As it stands right now, we're over 20 patents submitted, so we have a lot of IP behind the technology that we're putting into the marketplace, and we're really excited to be able to share what we're doing. To date, our major growth has been in advanced manufacturing in the HSE side, but we're starting to see the supply chain management logistics part of industry start to come online as well. So we're pretty excited about the opportunities there. We have a little video that we're going to show you just to kick this off.
Introducing smart space technology from ZeroKey. Modern factories and logistics centers are getting smarter, but human factors still plague these environments, causing expensive downtime, reduced production yield, and ballooning overhead. Smart Space is a breakthrough product that unlocks unprecedented insight and digitization of industrial operations of any scale. Patented 3D localization technology from ZeroKey digitizes manual workflows and processes down to the millimeter, so you can identify process bottlenecks, automatically detect errors in real time, optimize processes with powerful analytics and digital twinning, and improve safety in dangerous environments.
So how does smart space work? Essentially, what we're doing is we're enabling digitization, measurement, and data gathering in industrial environments that could be like warehouses and manufacturing facilities. We install anchor nodes into the environment. We put trackables on anything from an AGV to a forklift to an individual pallet, what have you, and we start tracking. So essentially, the anchor nodes get positioned in the environments somewhere between 30 to 40 meters apart. And once those are put into place, they actually go through a self-calibration where they actually find the nodes that are in close proximity to one another. The whole network ends up becoming a mesh network. So we can start to build from room scale to multiple room scale to multiple level scale, whatever a client needs to do. And it all meshes together seamlessly at the end. One of the other cool things about our technology is that we have the capability of working on near line of sight. So things like occlusions or obstacles being in our way, if they're relatively small, they don't create a big problem to us. So if you think of it kind of like water traveling through a stream, and if a stone is in the way, it just flows around it. Sound is very similar. So we have that capability of maybe it reducing our super high effectiveness for a split second, but once the item comes into clear view again to our nodes, boom, we go straight back to our millimeter level. So we have that capability and a lot of redundancy built into it. If an environment is a little bit more complex, all we do is add more nodes. So we just want to make sure that we're capable of tracking at the level that the client wants to track in their environment. So we build it accordingly. When it comes to the trackables, these nodes come in a wide variety of formats or form factors, if you will. And essentially we attach a node to whatever you want to attach it to. So could be, as an example, the two on the screen are attached to individuals. We could have little tiny nodes that are attached to something. We could have nodes that are a little larger in form factor because they have a battery in them. So essentially, at the end of the day, the core technology in each one of these nodes is going to be the same core technology. What happens is once those nodes are on an item and in that environment that's being tracked, we're going to get real-time 3D tracking, and we're going to have that millimeter level. Each one of these nodes is uniquely identifiable. So depending on how a client wants to track whatever is being tracked, we can make sure that the back end is able to annotate that node to the right thing, whether it's a SKU, an employee number, whatever it may be. The nodes, as I mentioned, come in different form factors, and sometimes that's based on the power source, or often that's based on the power source. So with trackables, we can put a trackable onto something that has a power source, and we can tie directly into it, which you'll see in a video a little later. In the instance of the two that you see on the screen, they both are rechargeable batteries and just a micro USB for recharging. And our smallest nodes can run off something like a CR2032 watch style battery. So really small, very flat, means our nodes can be quite a bit smaller as well. So when it comes to the system architecture, it's really quite simple. As I mentioned, we install the nodes into the room, the multiple rooms, the building, whatever it is we're tracking within. The sensors or the trackables go on to whatever that may be. And as you see here, there's power tool, person, could be anything, pallet, part, anything you like. The data collection is all going to be coming through the power over Ethernet, is going to transfer that information back to whatever source we want to use for the data collection. And then there's going to be the output of data. The technology for the data collection can be an on-premise solution, or it can be a cloud solution. And that's really driven, again, by client desire, client need. We don't have a requirement to tap into Wi-Fi, or if there's a local LTE, 5G network, whatever may be installed in newer buildings, we don't need that. The PoE is going to be able to get that information to where we need it to go. And when it comes to how the information flows and who is going to aggregate it, again, two options. We can provide that to a client in a raw dump of information, or we can actually aggregate it and provide it out as a dashboard with some intelligent insights for clients to be able to work with and build for the future. So here's a little matrix that we have, which is kind of a product comparison to other technologies in market. The interesting thing that you'll see in our technology is that we kind of jump out in many different categories. And that's primarily because we're doing something that hasn't been done before. So our accuracy is at 1.5 millimeters. If you look over along the line, ultra wideband is going to be our closest competitor. That's at 15 centimeters, so 100 times less accurate. We're doing this in 3D real time, which again, ultra wideband is really going to be our biggest competitor there. Our battery life is excellent. Obviously, we're using power over Ethernet for our anchor nodes, but we can maximize our power life with our trackables, because the trackables are capable of being essentially adjusted individually. So depending on the update rate, we can increase or decrease how long a battery is going to last. And if it's something that's going to be used maybe for an entire shift, if it's something tracking an individual, we're going to put a rechargeable battery in there so that you can get 2-3 days of work and then recharge. And as I mentioned before, the self-calibrating piece of our technology is really unique. So being able to mesh that network together really makes it a really scalable solution for room, building, multiple floor. Then one of the really interesting things that we find often as a question from clients is industrial environments do not negatively affect us. The issues with metallics in big warehouse environments and such just does not have the same impact on us. So we can still maintain our 1.5 millimeters, whereas something like a ultra wideband or Bluetooth is going to find quite a negative impact for those types of environments. So what does it all come down to? At the end of the day, we're trying to allow clients to optimize their processes, their personnel, and we're trying to reduce errors, provide higher quality control, and much more efficiency of flow in their processes. And all of this obviously provides a financial return to a client at the end of the day. So because we can digitize things that have never been able to be digitized before, we're actually providing data to clients that they've never been able to capture before. The high accuracy tracking of processes is a really interesting thing that we're super excited to show you in a video shortly. We can overlay our technology with different AR and VR solutions that are in the industrial environment. And as I mentioned, at the end of the day, we're capturing data that is capable of being used by you and your organizations to make smarter decisions down the road. One of our goals is to make things like RFID and barcodes become obsolete in the industrial space, because you just won't need them anymore. Our solution will be able to bridge the gaps of multiple technologies. And driving machine learning in the back end of things, obviously AI, machine learning, very big part of what's happening in industry and in the world as a whole, and being able to provide our rich spatial data back to clients is a very, very powerful tool. And as I mentioned, when it comes to what we call actionable insights, this is something that we can provide a raw dump of data to a client to be able to achieve, or we can dashboard it and provide that customized output of the information. Can be on-premise, can be cloud-based. We're agnostic when it comes to that. Again, very much up to a client. And it's really all about providing the insights to a client to be able to understand what could be changed, what can be changed, how things can be changed, because we can just track in such a different way than has been capable in the past. Here's a little video of one of our workbench installations. So as you can see, every time Kyle does something accurately, green lights up. Right now, he's actually being tracked on what order he's putting in the torquing in the bolts. Oops, he made an error, so it flashes the red. So just got a couple screenshots from that image. As I mentioned, when Kyle made that error, it flashed red. So he's getting real-time feedback on what's happening. And I'll just give you a quick layout of what's happening in this video. We're using our dev kit to do this. And as you can see, Kyle's wearing a wristband on each wrist. So we're tracking his hand movements. We're tracking the torque wrench that's in his right hand, and there's a node on the end of that. And we've built an offset, understanding how long the bit is to know when he's actually on the bolt. And the trigger of that torque wrench is triggering the sensor, so we know when it's going through the process accurately. What you can see on the screen that he's looking at is he's getting a written workflow of what he should be doing. He's getting an image of the diagram of what he should be doing, and it's highlighting the things. As you could see, that the bolts would turn green when it was its turn to be torqued onto the pump housing. And we just have our anchor nodes for our dev kit around the top of this workbench to be able to track all of those movements and understand what's going on. The green, amber, and red lights that pop up on the board essentially are telling him real time, are you doing the right thing? Did you make an error? This is something that we apply to many different spaces, but one of the big areas is actually a moving manufacturing line. So if something is moving down a line and an error moves down that line, that can become a very costly error. If you can capture it right away and be able to make that adjustment in near real time, then obviously there's a lot of savings that can come through to a client. The other thing that we can track here is the cycle time. So you can understand from the data that comes out of this, how long does the average cycle time for each of the different processes. Often in a manufacturing line, different processes will happen item by item. So if it's a car, for example, car by car, there may be a slightly different process. So being able to track that in a really fluid manner in real time is very, very, very powerful. And essentially, what we've done here is because we can track so accurately the items that we have the nodes on, we've created a digitized space or version of this workbench. And so we know very precisely where each one of those bins is. We know what part is in each one of those bins, and that can be extrapolated into all kinds of different types of processes. So I just wanted to provide a couple more of the use cases that we're seeing a lot of action in these days, just to explain how we're working in them. So supply chain management and logistics, handpicking is still a very, very big piece of supply chain management. Obviously, robotics is something that is growing, but not all things can be roboticized. So the handpicking piece of that is still an area where fulfillment can be very slow. Obviously, if errors are made or the process is not running smoothly, that slow supply chain is just going to erode margin as you move through your business process, whether manufacturing or otherwise. So using our technology, we have a number of different things that we can do here, but one of the coolest is that we can overlay our technology using something like a Google Glass or a heads-up display, whatever type of smart device you want to use for augmented reality, and we can give that heads-up display to a worker. And essentially, what we can do is we can begin to guide them around the environment that they're working in. So we can start to give them a faster path between item and item that they need to pick. You can get rid of things like having a pick list, whether it's on paper or a tablet, and all of those picks can be pushed up to the heads-up display. And really what we're trying to do is optimize that individual, being able to move around the environment and pick the right items. When they get to the item, they're told exactly how many, and they are even given an image of what it should be. And the outcomes from this are pretty significant. Being able to increase picks per hour, you can increase your efficiencies by 35%. Your latencies can be reduced by 30%. And training costs, which are with some of the clients we're working with are very, very significant, can be reduced by up to 90%. And the rationale being that you can almost just put the glass on somebody and the directions are provided to them to be able to go about what they need to do in such a simple manner. That training process just gets shrunk down significantly. An area like AGVs and forklifts or AMRs in industrial environments, these types of tools are obviously quite widespread. Forklifts probably will become AGVs, not in the too distant future. One of the problems with the AGVs in industrial spaces is that they use magnetic strips, and those magnetic strips essentially become the pathway, as you know, for guiding route to route where they need to go, but they're very confined in how they can work. It has to follow that path. If you want to change the path, you need to tear up the strip and redo the strip. Newer technologies out there, obviously, LiDAR, radar, cameras, all kinds of different things that are happening. But we still find that there's a problem with those AGVs getting lost or stuck in an industrial environment. And what we found is we can actually overlay our technology to be able to enhance the guidance of those machines. So again, by having our anchor nodes in the environment and our trackable on the actual AGV, we know where that AGV is all the time. And we know if it's got to turn left, turn right, or if you want to change the path, we can create that capability very easily and build it into the ROS system and enhance what it's capable of doing. One of the big things here is being able to stop the issue of potential shutdowns. We've actually even been doing a tour of a facility where an AGV got stuck, and it was at very close intersect to an intersection and essentially stopped traffic in 4 different directions because people couldn't safely move around it. So that obviously can be quite a significant issue if you are stopping production because of that reason. Just to jump into what the pricing looks like related to our solution, our development kit, which I mentioned, that's $5,000, and if you go out to our website, you can submit to get a quote sent out. Essentially, comes with 6 anchors, 2 trackers, the dongle, which allows you to connect to could be a tablet or a computer for being able to access our SDK. This is designed for smaller use cases. So these nodes are really going to max out at about 6 meters apart. Once you get beyond that, you're going to be compromising the millimeter level accuracy. You can do it, but you will pay a little price for that. And we recommend either, if it's a small enough room, a square, but a U shape is actually quite often the most efficient that we find for people to be able to set up their use case testing. For the smart space technology as a whole, when we're looking at large scale installations, we work with a hardware as a service solution there. So for facilities that are 50,000 square feet and larger, we work at $2 per square foot, and that gets you our anchor nodes in place, our software all set up. It's going to provide you with support and whatever else you need on the term contract that we set up. And the only additional thing that you require on top of that would be trackables. And trackables depend on the form factor and what you're trying to achieve and how many you require. So that's the only add-on to that. Just a couple of highlights of things that have been exciting for us over the last 12 months-ish. We were really excited to be included in Gartner's Cool Vendors list back in, I guess that was May. It seems like it was yesterday. It was pretty exciting for us to be called out as a cool vendor, and basically a cool vendor to Gartner is a technology that they see as being an exciting emerging technology coming into a space, and we're in the location services. Back in June last year, we won the machine demo competition at Collision in Toronto. That was again a really exciting opportunity for us. And then in January of this year, we were actually called out in Gartner's Magic Quadrant for indoor location services. The really exciting thing here is that we don't actually qualify to make it onto the Magic Quadrant. We're too young of a company, but we got called out as a vendor to consider in a short list because Gartner sees what we're doing in the marketplace and really thinks that there's an exciting opportunity for us to grow and grow. Just want to put a little plug into our new websites. Go out, take a peek. We're constantly updating it now. Almost every day it's getting updated. We have some downloads out there, whether it be some technical documents, white paper. As I mentioned, you can download to get a quote for the dev kit, and we'll be constantly adding new information out there that could be very valuable for you. That's it for me, and if there are any questions, as I said, drop them into the chats, and Matt should have a bunch in the list already.
Yeah, so I got a few that people submitted beforehand and a couple that came through during the presentation here. So just to kick it off here, the first question is, how does smart space compare to ultra wideband?
Well, I kind of highlighted, when I showed the comparison. Ultra wideband is not going to be as accurate. It's at centimeter basis, where we're at millimeter basis. And once you put it into an industrial environment with a lot of metallics, it's going to lose that 15 centimeters and get wider and wider and wider in its lack of capability of maintaining. So we definitely are more accurate. We're a more agile solution to put into an industrial environment. And at the end of the day, the ROI is going to be far higher as well.
Great. And a follow-up to that one, with 5G right around the corner and expected positioning accuracy on the order of 10 centimeters, how do we compare to 5G?
Well, I would say it's going to be very, very similar to what I just mentioned with ultra wideband. at 10 centimeters, it's still nowhere near the accuracy that we can gain. And you're not going to be able to do what we can do when it comes to the digital twinning and being able to really track a process super accurately to be able to get that data out of it. So it's going to have the similar types of limitations.
Great. Moving on to the next one. What components are needed for a full solution?
Well, the anchor nodes and the trackables are the key components that you need. As far as where the data gets stored, as I mentioned, that could be in your client technology, or it could be in our technology, and we're going to provide that out in a dashboard. Essentially, once we've deployed our anchor nodes in that subscription service, that includes all of our software behind the scenes, all the support, and then it really comes down to what do you want to track. What are your business cases? What are your use cases? We need to figure out which trackables are going to be most appropriate. Those are put into the solution, and then the output of that information is either going to be done in-house or we can assist you there.
Okay, and the next one, how are workflows configured for tracking?
Well, there'll be a couple of different ways to do that. The workflow that I showed you on the workbench, we actually use our trackables to teach where all of those things are located on the bench. So essentially, once we place a tracker over top of one of those bins, we can allocate that bin and digitize the environment and just move along. So if there's 6 bins, we know the size, we can design it accordingly, and we can match that flow very, very easily.
All right, and last question I have here, is the $2 subscription a monthly fee?
It's as it mentioned on the excuse me, on the form. It's a $2 subscription based on square footage. It ends up being a monthly fee, and we build it into a term contract. Generally speaking, somewhere between 3 to 5 years.
But just to clarify, it's $2 per square foot per year.
Yes.
Great. Okay, so those are all the questions. We got just a couple of minutes. If anyone had any last minute questions, just send them through in the chat. Otherwise, we'll wrap it up here in the next minute or so.
And definitely, if anyone has any follow-up questions, my email is right there. Definitely shoot me a note, and we have a lot of information out on the website.
Great. And we're going to be throwing this webinar online as well. So you can always catch it there if there's something you guys wanted to refer back to. I don't see any more coming through. So why don't you just close her out there, Richard?
All right. Well, thanks a lot for joining us for our second webinar. Hope it answered the questions you were looking for and piqued your interest and insights into what we're capable of doing. And we look forward to talking with you in the near future.